Hello everybody, in this lesson I will deal with the first two laws of exponents. Law 1. When I give you a to the m times a to the n, the answer is equal to a to the m plus n. So how this works is you say when your bases are the same and you multiply, then you add exponents. Now, when I give you 2 to the 2 or 2 squared times 2 cubed, this is the same as 2 times 2 times 2 times 2 times 2. And then when you work all of that out, you find the answer is 32. Now instead of doing that, writing it in expanded form, you can use the law. So the very same sum, 2 to the 2 times 2 to the 3, when you use the law, you say the bases are the same, which is a 2, and when you multiply, you add exponents. So you write 2 once, a2, and then the exponents you add. 2 plus 3 there, 2 plus 3. So the answer is 2 to the 5. And 2 to the 5 is, let me show you on your calculator how you can work it out. Now there's a button there. Can you see it's an X and then there's an exponent that's a square. So what you do is in X's place, when you press that button, the base you put 2 and then for the exponent you put 5 and equals, and then you get the answer 32. Let's look at another example. If I give you 3 to the 3 times 3 to the 3, you say the bases are the same and you multiply, therefore we add exponents. So the base that's represented is a 3, and then the exponents 3 plus 3 is 6. 3 to the 6 is 729. You can work that out with your calculator since you know how to do it now. 2 to the 4 times 2 to the 3. Bases are the same, we multiply, therefore we add exponents. So it is 2 to the 4 plus 3, which is 2 to the 7, and when you work it out, it's 128. Let's look at more examples. 7 squared times 7 to the 0 times 7 squared. So what you do is you say the bases are the same, which is a 7, and you multiply, therefore you add exponents. So the base is 7, and then the exponents 2 plus 0 plus 2, and then it's 7 to the 4, which is 2401. Now with variables, b to the 5 times b to the 6, it works exactly the same. The base that's represented is a b, and we multiply. We're going to add exponents. Therefore, it's b to the 5 plus 6, which is b to the 11. 5 squared times 5. Now the reason I gave you this sum is if you look at this 5, there's no exponent, but in fact there's an invisible 1. So if there's nothing there, there's an invisible 1. And then you say bases are the same, you multiply, therefore we add exponents. So it's 5 to the 2 plus 1, which is 5 to the 3, which is 125, not 15. X to the 4 times x to the 8. Bases are the same, we multiply, therefore we add exponents. So we write an x, and then on the exponents 4 plus 8 is 12. So the answer, x to the 12. Let's look at law 2. Now law 2 deals with division. And then again, we've got a to the m divide a to the n. And then the answer is the base is a, and on the exponents we subtract exponents, m minus n. It's always the one you find first minus the one you find second. And then even if it's written as m to the a to the m divide a to the n like that, in this one, you will say it's a to the m minus n. So this a will go and stand on top of that one, and you subtract top minus the bottom exponent. If I give you 5 to the 7 divide 5 to the 5, then it's 5 to the 7 minus 5, which is 5 squared, and 5 squared is 25. When I give you 2 to the 6 divide by 2 to the 3, what you do is you say the bases are the same and I divide. So this 2 will go and stand on top of that 2, and division is subtraction of exponents. 6 minus 3, and the answer 2 to the 3, and 2 to the 3 is 8, not 6. 3 to the 4 divide by 3 to the 2. So the bases are the same and I divide. I'm going to subtract exponents. It becomes 3 to the 4 minus 2, which is 3 squared, which is 9. 2 to the 8 divide by 2 to the 5. So the 2 will go and stand on top of that one. It's division, we subtract exponents. Therefore, it's 2 to the 8 minus 5, which is 2 to the 3, and 2 to the 3 is 8. 8 to the 11 divide by 8 to the 9. Then we say division, bases are the same, we subtract exponents. So the base that's represented is 8, and then the exponent is 11 minus 9, which is 8 squared, and 8 squared is 64. 15 to the 7 divide by 15 to the 6. The bases are the same, therefore I subtract exponents. It will be 15 to the 7 minus 6, which is 1, and then the answer is just 15. We don't write that invisible 1 over there. Let's look at more examples. b to the 9 divide by b to the 7. The bases are the same, therefore we subtract exponents. So this b will go and stand on top of that b, and we find b to the 9 minus 7, which is b squared. N to the 11 divide by n to the 8. Bases are the same, we subtract exponents. Therefore it's n to the 11 minus 8, which is n cubed. A to the 6 divide by a to the 4. Bases are the same, we divide, therefore we subtract exponents. And it becomes a to the 6 minus 4, which is a squared. 6 squared divide by 6. Now this one at the denominator, since there is no exponent, it implies there's an invisible 1. Therefore, it's going to be 6 to the 2 minus 1, which is just 6. Law 3. Now this one, we say we are raising a power to a power. So that means it's a to the m raised to the power of n. And what you do is now you're going to multiply the two exponents. So this one is a to the m times n. Then my advice to you, remember bracket means multiplication. So that's how you're going to remember to do that one. Now let's look at this example. When I give you 2 to the 3, I mean 2 to the 2 raised to the 3 is 2 squared times 2 squared times 2 squared, which is, when you use law 1, bases are the same and you add exponents. Then it becomes 2 to the 2 plus 2 plus 2, which is 2 to the 6. Now if you use law 3, 2 squared raised to the power of 3, the bracket means multiplication, and the answer is 2 to the 2 times 3, which is 2 to the 6. Now let's look at this. When I give you the expression a to the 4 raised to the power of 5, in the second column, let's write it as a product of the powers. That means it's a to the 4 times 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 a to the 4. And when you multiply and the bases are the same, you add exponents. That's law 1. Therefore, it's a to the 4 plus 4 plus 4 plus 4 plus 4, which is a to the 20. And then in the last column here, if we use law 3 to simplify, it's going to be a to the 4 times 5, which is a to the 20. The second one, b to the 10 raised to the power of 3. As a product of its powers, it means b to the 10 times b to the 10 times b to the 10. And then when you use law 1, bases are the same, we add exponents, we end with b to the 10 plus 10 plus 10, which is b to the 30. And then in the last column, if we use law 3, it's simply b to the 3 times 10, which is b to the 30. And then the last one here, 3 squared raised to the power of 4. As a product of its powers, it's 3 squared times 3 squared times 3 squared times 3 squared. Law 1 is when bases are the same and we multiply, we add exponents. So it's 3 to the 2 plus 2 plus 2 plus 2, which is 3 to the 8. And when we use law 3, it's simply 3 to the 2 times 4, which is 3 to the 8. Use the exponent laws to simplify the following. Now, when I give you 3 to the 7 raised to the 2, remember the bracket means 3 to the 7 times 2, which is 3 to the 14. 8 to the 11 raised to the 3, bracket means multiplication of exponents. Therefore, it's 8 to the 11 times 3, which is 8 to the power of 33. b to the 4 raised to the 3 will be b to the 4 times 3, which is b to the 12. n to the 6 raised to the power of 4 will be n to the 6 times 4, which is n to the 24. Now on this one, you must be very careful, because the 2 is outside of the bracket here. It's got nothing to do with the power to the power. So you will just write down the 2, and then on the exponents it will be 2 to the x 3 times 5. Why? Because of the bracket. And the answer 2 to the x, 2x to the 15. And then this one, now 4 squared, you can work out. 4 squared means 4 times 4, which is 16. And then on this one, a to the 3 raised to the 6 will be 16. A to the 3 times 6, and that is 16a to the 18. In the next video, I will deal with some calculations with exponents. Click on the video in the left-hand corner to take you straight to the next video.